Hello, everyone. Thank you so much for being here today. Today, we're going to talk about grappling with Scatter Spider. So, before we focus more into this cloud warfare that we've been going on and uh, dealing with these guys, first, let's have a look at the agenda to provide a more structured look of what we'll be discussing today. First, we'll do an introduction. I'm going to introduce myself, and my colleague will introduce himself. Then we're going to talk more about understanding Scatter Spider, or the way that Permiso calls it, Lucre 3. I'm going to explore and dive more into modern cloud attacks, and then we're going to explore AWS TTPs. That's where they are more active at. Then my colleague will explain cloud logs for defenders. He's going to dive into logs a bit to explain how the logs work. Then we're going to hunt and catch these TTPs using his tool, Cloud Grafter. And in the end, we're going to summarize everything that we talked. So first up, introduction. I'm Abian Marina. I'm an associate threat researcher at Permiso Security. I've recently finished my bachelor studies, and I've been initially started into cybersecurity through hacking cameras and video games. And then I found out that this could be a legitimate career path and started studying cybersecurity. Uh,
Yep, thanks, Samten. So, hello everyone. My name is Andre Ahmeti. I come from Kosovo, which is a small country located in the Balkan region in Europe. I've been working as an associate threat researcher for more than a year now, year and a half. We've been having a great time finding evil in the cloud, and yeah, while doing that, we also developed some open source tools. One of them is Cloud Grappler, the one we're going to talk about it today. And the second one is Cloud Console Cartographer, an open source tool which I co-authored with my manager, Daniel Bohannon. On my free time, I like to watch football. And by football, I mean the real football, the one you play with foot. So yeah, not the best there. Like, is the real one. Yeah, I'm gonna pass it over to my dear colleague.
Lexi. So in our current role, we focus on investigating malicious activities, researching new detection techniques, and developing tools to strengthen cloud security. We work closely with our PO Labs team, and we ensure that our client infrastructure remains secure. Permiso as a company acts as a vigilant defender in the cloud, protecting both human and non-human identities across IDP, IaaS, and PaaS. By leveraging machine learning and over 1,000 detection rules, we help organizations strengthen their identity security posture, ensuring only that high fidelity alerts are triggered, such as from groups like Scatter Spider. Okay, so next up, let's move into the fun part, understanding Lucre 3. So, Lucre. Every organization tends to have their own name, and this is ours. So, Lucre is our financially motivated threat actor groups, and you might have known them more as Scattered Spider, which is a name that's broadly known about. You'll also hear them being called Octopus or Roasted Octopus in various reports. Mandiant refers as them as ARM3944, and Microsoft initially called them Storm 0875 before transitioning into the name OptoTempest. Mission-wise, Lucre 3 is all about financial gain. The journey started with small-scale activities like Roblox gift card schemes. This was where they first got their feet wet. From there, they transitioned into the crypto mining phase, but they didn't stop at that. They quickly moved into extortion. And when I'm talking about extortion, I'm talking about millions of dollars in extortion requests. What's particularly notable about Lucre 3 is their persistence. Just 3 months after a successful extortion, they're often back trying to strike again. If a company paid the extortion fee before, they'll bank on the idea that you'll pay it again. And if you didn't pay the first time, they'll try to make the situation even more painful the next time they're around to increase the pressure to get what they want. So initially, they targeted telecoms, leveraging SIM swapping tactics to gain control of phone numbers. This was their bread and butter early on. After telecoms, they shifted into big software firms, uh, focusing on stealing code signing certs and source code, which allowed them to demand high extortion fees. They worked on this angle for about a year until it became less profitable. As opportunities in software dried up, they expanded into other industries like gaming. Uh, so in gaming and healthcare, focusing on each sector for a few months and then moving on to the next. Recently, however, their targeting has become less predictable as now they're hitting multiple industries at once, showing their persistent pursuit of financial gain. Okay, let's talk about what they do and their consistent themes. First of all, they do their homework. They do targeted personas. Uh, they check the guys that they want to uh, get control of. They usually go after three types of personas. First is identity admins. These are the folks managing Azure AD, Octane, basically controlling access to everything. If they can compromise these accounts, that hit the jackpot. Second, if their goal isn't stealing intellectual property, but rather disrupting services, like in gaming industry, they go after sysadmins because these are the people keeping everything running. So taking them down can cause a lot of damage. And three, there's us, like security folks. Uh, we often have elevated privileges, and let's be honest, we sometimes we whitelist our activity and don't pay much attention on our own activities. Lucas Tree loves this. They want us to know that they've been in our environment, but only when they're ready to hit their move and extort us. They use a lot of GUI tooling. I'll talk about that later since we're short on time. Very little malware used in the cloud and SaaS environments. They rarely use malware. When it comes to on-prem, it's often with classic and well-known techniques. They're opportunistic about the tooling that they use. They don't care if you're using Slack or Teams or if you have Notion or Confluence. They'll use whatever tooling you have against you. Finally, they like to watch and learn from what you're doing, gathering intel to make their attack more effective. Okay, let's take a high-level overview of how a modern cloud attack typically unfolds. So when people talk about cloud attacks today, they often focus only on AWS or Azure portions, but that's just one part of the picture. The reality is that everything is interconnected, starting from the IDP. And once they're in, the attackers focus on learning about your environment. They'll move into your SaaS portals, running queries just like a regular user would do. They use SaaS to gather information needed to carry out their mission, whether they're targeting your IaaS for credential harvesting and data theft, or diving into your CI/CD pipeline to steer source code or code signing certs. By the time they're executing their mission, they've gathered everything they need to know about your environment to make the attack happen. So for the IDP side, again, they're doing their research. They pick a person that they know where they're living at, so they can emulate that access pattern. So much so in specific engagement, the attacker was coming from the same exact ASN as the victim user normally comes from. And with access patterns being so similar from the IRS stance, it's really hard to tell good from bad. Adding to that, they're using residential proxies to get close enough to avoid triggering any geo-restriction or feasibility rules. This means they can log in from locations that look very similar to the legitimate user that would normally be accessing from, further complicating the detection. When it comes to credentials, they'll do whatever they have to do to get them. They'll buy, coerce, or bribe their way into creds. Sometimes they'll even set up targeted phishing infrastructure to harvest those credentials. Once they've got the creds, getting past MFA can be as simple as a SIM swap or push fatigue, even with hardware tokens, which are a solid defense. It's not a guaranteed barrier. They'll still pick up a phone and say, hey, for like $2,000, can you push a button for me? And sometimes that works. And once they're in, they know how difficult it was to get in. So they make sure that they don't have to go through that again. They immediately register their own MFA, usually switching to SMS, and they'll also set a new email for password resets to further secure their control. So when it comes to hunting opportunities, how many people in your environment, use more than one phone? Me and Andy don't use the same phone, right? Yeah. You'll likely find a few, but it shouldn't be too many. How many people switch platforms? We've only seen these guys use Apple devices, never Android. So how often do we see someone switch from Android to Apple and back and forth? So you should see a bit during holidays, but it should be a small enough data set to hunt through. Also, how often do you see someone with an iPhone 15 suddenly register 11 or 12? No one really downgrades phone, right? These abnormal patterns are the ones that you should be looking for when not dealing with straightforward malware. So for the SaaS side, the challenge in detecting these threats. Okay.
You being hacked by Looker.
The Looker 3 is here. So the challenge in detecting these threats lies that, in fact, there's no malware used. Attackers use the same APIs and function as legitimate user would, so making it hard. Okay, once they gain initial access to your IDP, their next move is to quickly learn as much as they can about your environment, often starting by exploring knowledge sharing resources like wikis or Confluence. These search terms can reveal the intent of the attackers. For instance, ScatterSpider has been seen using specific search terms across different environments like AKIA for AWS credentials, clearly indicating that they're hunting for access keys. Similarly, when they search for something like a Shodan API, Shodan API key, it's not the key that they want, but it's actually the script that reference to it to understand how you're enriching data. Another crucial detection opportunity is monitoring user behavior patterns. If a long-time employee suddenly starts using applications like GitHub, for example, which they've never done before, that's a significant red flag. From a least privilege standpoint, these are the applications that should have been removed from their access a long time ago. However, enforcing least privilege effectively is a challenge for most organizations. Also, for defense evasion in 365, attackers often cover their tracks by setting up automated email deletion rules. They use less common filters like body contains to target specific terms in the body of email, ensuring any communication that could expose them is immediately deleted. This tactic is used, obviously, by to hide their activity and to make detection and even more challenging. Okay, so next up, we're gonna dive into exploring AWS CTPs, which is where they're more active. So let's talk about S3 Browser a bit. What's concerning about S3 Browser is, so for those that don't know, S3 Browser is a GUI tooling that is used to show like what Amazon does, but you have it without complicated command lines. So what's particularly concerning when it comes to S3 Browser is that is used when it's used for IAM functions, such as creating new users, uploading or updating login profiles, or altering permissions. So these are the tasks that normally are done by more secure and auditable permissions, audible channels like AWS CLI or the management console. So if these sensitive actions are being carried out through S3 Browser, it's a strong indication that something unusual or potentially malicious is happening. Attackers frequently use SSM to run scripts, such as software inventory gathers on all EC2 instances. Rather than running these scripts just once, they schedule them to execute every 30 minutes, maintaining a persistent presence and continuously gathering data. Attackers focus on AWS Secrets Manager. They use Cloud Shell, a method which is rarely seen in legitimate operation to extract these secrets. While looping through secrets with the get secret value command, they can pull all the information they need which is major red flag. They also do file uploads and downloads via Cloud Shell. Attackers upload and download. They replace an instance profile to grant EC2 instances over permissive roles, often using a simple star policy. Instead of creating users or access keys, they quietly add login profiles to existing accounts, set passwords, and take over those identities. Disabling guard duty is typically one of their first moves. While many security teams have rules to detect this, it often creates more noise than it's worth. More interesting is attackers delete guard duty invitation and dissociate from the master's account, making it more challenging to re-enable guard duty. Stop logging. Attackers believe that will halt the logs. The reality is that it just prevents the logs from being sent to their destination, meaning that if you're hitting or monitoring the API, you can still capture these events. And also check out for EC2 instance anomalies. They frequently create large, extensive EC2 instances on... go ahead.
No, thank you, Miguel. Yeah, I'm gonna go quickly since we don't have time. So Albion gave us a great insights of how these attackers, how the attack was their pattern, was their tactics. Now the real challenge is how to actually detect them and see if they are present in your environment. Now we're gonna talk about cloud logs for defenders, and let's start from a basic of what is a log. Now some of this might be ABC for you, but it's just worth talking about it. So a log is a fact which could lead up to an incident, but not at all times, about who did what and when in your environment. So basically logs are visibility. You can see from a log which identity did what and when. But in order for you to have this kind of power, you need to have the logs available. Some CSPs offer, some of their service offer logging enabled by default. Some of them don't. You always want to make sure and double check. So you hit that on button because an attacker won't do that for you. Next thing is store the logs to a secondary location. Or there are pretty cheap options like an S3 bucket or a blob storage where you can store your logs so you can keep them for a later period in case you need to search for malicious activity. And the next thing, after you store them to a secondary location, you want to aggregate them, correlate logs, and the most important part is search for malicious activity. So at the end, we can pretty much confidently say that the logs shine our path towards the truth. The truth can be harsh sometimes, but in our case, we always prefer the truth. I'm not going to stop here pretty much. Cloud logs, we know that cloud is awesome. You have a serverless architecture. You don't have to worry about the physical server, blah, blah, blah. But there are some cons if you are dealing with, if you're a blue team person. Now, they are determined by the cloud providers, so you don't have much saying on what do they offer you. Next thing is delay and log generation that is dependent on various factors like internet speed. The retention limit, some of them have a 90 days retention limit where they save your logs. Some of them have a 30 days limits, so there comes the part of storing into a secondary location, and they are far more abstract. So if you dealt with an on-prem log and you switch back to a cloud logs, you'll see what I'm saying. Cloud logs in AWS, you can view them through the console, through the CloudTrail API. Same goes with cloud logs in Azure. Cloud attacks in the wild. Albion said the most of it. Now we're gonna go to the Cloud Grappler, which is public since March this year. Is a long story short, it's a threat detection framework. It's built with our all the TTPs that Albion mentioned, and you can scan your environment to see if there are any indicator of these threat actors in your environment. So yeah, the first and most critical part, most important part of Cloud Grappler is threat actor clearing. Till now, we have around 140 TTPs public available to the GitHub repo, and these TTPs comprised of different threat actors, not just Looker 3, but it's the most important one. We have Looker 1 or GUI-Evil. We have some other tools that have been used, like Andro Ghost. And the most important one, and latest one, is the LLM hijacking. So yeah, Cloud Grappler catch the bad guys in your environment and lets you know if you've been hit by them. Next is single event detection. Till now, it's AWS and Azure. So what I mean by single event detection is Avian mentioned there are some event names or like events which can happen in your environment. They are not necessarily malicious, but these threat actors tend to love them. So if you see, for example, the get file download URLs, so someone is downloading something from your Cloud Shell, so it might be a secret, it might be maybe a password file, so you always want to check them out. Till now, we have pretty much feedback from the community of why GCP is not integrated. And now we can probably say that we have integrated GCP also with some TTPs. So we have the three biggest CSP, and the next one, I don't know, I might be getting some feedback from you or someone else if they want to see a CSP online. CloudGrab is another open source tool developed by Chris Doman. So CloudGrab is the main core of Cloud Grappler. It just graphs for cloud storage, and Cloud Grappler is a wrapper script with our TTPs. How can you configure it? So you have the scope selector where you can define your scope. So I think this is the most important part. So you have the AWS. You have to define your bucket and your prefix. If you want to specify prefix, I would recommend that, since if you just only put a bucket and you have like 1 terabyte of data, the processor is going to be slow. So always make sure to put a prefix there. Same goes with Azure. Put the pump name and the container, and at the end, that you use one GCP. So no prefix here, just the bucket. So as I said, we have some predefined queries, like 140 of them, but you always free to add them. Let's say you want to check if a certain IP has hit your target, then you can add that. You just follow the pattern of the other queries. You want to make sure to give it a name. And the most important part is the query, where is the actual regex or the query that you are searching in your environment. The final one is the report generator. After the entire process is finished, you can just output a JSON format log. So if you want to check it further, I have a 1 minute demo. I think we have time. Yes. Yeah, we have. So just hit the help menu, see what features Cloud Grappler has to offer. It's easy, just hit call the mail.py function. This is the cool SDR we've been doing. So here is GCP, it's extracted data from this bucket. If you check it, the scan is complete. We have 3 hits. This runs very fast because it's a demo. It won't happen if you have more data, say. And same is with the AWS. Scanning for hits, scan completed. We found some hits. Next thing, what we do is add the Permisa Intel flag. So what this does, it gives a description for each query that is being ran. And we're gonna check it now, the fields. And also we're gonna put the -- JSON output flag, which says like every log, if we have a hit, just put it in a JSON format so you can use it for if you need to further investigate it. So yeah. Yeah, it's the same process. Yeah, as you can see, it's running get file download URLs. It has a threat actor which is tied to what's the severity and a short description of it. The process is the same. We're going to do a 3 command on the reports folder. So it creates a new folder called reports, and it was the structure of the report. Yeah, as you can see, 3 different CSPs, the time when the scan was finished, the name of the bucket, and the PDPs or the queries that they found. Yep. So summary. I think we can go with this.